Now that we've gone over how to assign oxidation states, let's work through some examples. So number one is just carbon. So as we saw from rule number one, any atom on its own has an oxidation state of 0. So carbon on its own will have an oxidation state of 0. So number two says LiH. The first thing I want to do when I solve an oxidation state type problem is set this entire molecule equal to its total charge. So LiH does not have a charge. So what I'm going to do is set this equal to 0. So I know that the sum of the oxidation state of lithium and hydrogen needs to equal 0. That is rule number 2. I should do this every time I have a molecule with multiple atoms in it. So we have lithium and hydrogen. So lithium pops up in rule number 3. All alkali metals in the first column of the table have an oxidation state of +1. So the rule that describes lithium comes before the rule that describes hydrogen, which is rule number 6. So rule number 3 will be more important. So let's assign lithium an oxidation state of +1. So now that we know lithium has an oxidation state of +1, what must hydrogen be? Well, +1 minus 1 equals 0. So we could use this algebra to solve for the oxidation state of multiple atoms. So in number 2, lithium has an oxidation state of 1, hydrogen has an oxidation state of -1, and the overall molecule has 0 charge. So for number 3, let's follow the same steps. We will set this equal to 0 because CO2 does not have an overall total charge. So let's see where our rules pop up. So I do not see a rule for carbon on the list of rules. So let's see where we find our rule for oxygen. So rule number 7 says that oxygen has an oxidation state of -2. So what we can do is say that because there are 2 oxygens, that both will have an oxidation state of -2, that oxygen accounts for a total of -4 charge. So how can we solve for carbon? Well, we know that carbon must be +4 because +4 minus 4 will give us that overall total charge of 0. MgCl2, we'll do the same thing. We'll set this equal to 0 because this does not have a charge. Let's see where we find our rules. So I do not see a rule for chlorine on this table. So let's see if we can find our rule for magnesium. Magnesium is an alkali earth metal. Rule number 5 says that all second column atoms have an oxidation state of +2. So we know that magnesium is going to be +2. So what does that mean for chlorine? Well, there are 2 chlorines, and we do not know the oxidation state for chlorine. So we can say +2 plus 2x. Remember, we are taking the sum of all of our oxidation states. It's going to be equal to 0. So we can simply solve 2x equals -2, x equals -1. So the oxidation state for each chlorine, remember there are 2 chlorines, is going to be -1. So magnesium will be +2, each chlorine will be -1. That will give us our overall sum of oxidation states equal to 0, which is equal to our overall total charge for magnesium chloride. What about HF? So we know HF is going to be equal to 0. There is no charge. So fluorine, which is rule number 4, says that it has a -1 oxidation state. That must mean that hydrogen has a +1 oxidation state. Rule number 6, or number 6, I should say, this molecule is going to equal 0. There is no overall charge here. So which rule comes first, hydrogen or oxygen? So hydrogen is rule number 6. It has an oxidation state of +1, and oxygen is -2. So we cannot quickly assign oxygen an oxidation state of -2. We have to follow the rules in order. So each hydrogen will have a oxidation state of +1. So there are 2 hydrogens times each one having a +1 oxidation state. We do not know the oxidation state for oxygen. So we will say plus 2x equals 0. So we can solve this. 2 plus 2x equals 0. 2x equals minus 2. X equals minus 1. So each oxygen will have an oxidation state of minus 1. Remember, there are two of them. Each one will have a minus 1 oxidation state. So CO3, 2 minus, what we should do is set this entire molecule equal to minus 2 because it has a charge of 2 minus. So the sum of all the oxidation states need to add up to minus 2. So what we can do, we know that carbon does not have a rule on our table, but we know that oxygen is minus 2. So we should say X for carbon, we do not know it, plus 3 oxygens times minus 2, because each oxygen is going to have an oxidation state of minus 2 equals negative 2. So X plus negative 6 equals negative 2. So X is going to equal positive 4. For carbon. Number 8, NH4 plus, we should set equal to plus 1 because its charge is plus 1. We know that nitrogen has not popped up on our rules yet, but hydrogen is plus 1. So nitrogen will be X, we do not know it, plus 4, there are 4 hydrogens, times each hydrogen has an oxidation state of plus 1. So this is going to be X plus 4 equals 1. X will equal negative 3. Number 9, MnO4 minus. Mn has not popped up on our rules yet, but we know that we need to set this equal to minus 1. So X plus, there are 4 oxygens, times each one having oxidation state of minus 2 equals minus 1. So X plus minus 8 equals minus 1. So X is going to equal plus 7. So the oxidation state of Mn is plus 7. So working through these examples, we can see how following the rules in order and setting each one equal to its overall charge will get us the right answer every time.